Okay, Aaron, just looking back at that question today that I got in a right muddle over. So let's look properly at it for a second. We forgot the fundamental thing when we were doing the weight component. We forgot about the cos of 30. Sure, it's at a bloody angle. We were thinking it was a straight line. So you can see there that it's not at a straight line. From A to C, it's at an angle of 30. So obviously when you're taking that into consideration, at the halfway mark where the centre of gravity is, so the weight multiplied by half AC cos 30, and that makes much more sense. And then we will write everything else. So the cos of 30 is equals to the adjacent over hypotenuse. The adjacent we can see there is the line they told A to D, which they said to call small d. And the hypotenuse, of course, is AC. Rearranging that equation to get D is equals to the cos 30 of AC. Fit that in for D into our equation that we had. The coses 30s at both sides and the ACs at both sides cancel out. And we've F is equals to a half W. So now we finally got the right answer, which is 6.9 newtons. So what we forgot was to take the cos of 30 into consideration in the one that we did together today. So just a little reminder there, and there's no harm we double check ourselves and don't forget that it was a vector question. Okay, moving on to the direction one next. So let's just take a look here. Now, you could get the same answer but different directions, which is fine because there's a couple of different ways of looking at this. So what I have done here is you can see there in the diagram, first of all, I have divided the S vector into its perpendicular and its horizontal component. Okay, now forget the arrow going up north. That was just kind of out to fool you with the dotted line, really, because you can quite obviously that even without even starting, that from Newtonards down to Enniskillen, it's going from the compass above, you can see it's going southwest. That's quite clear. Okay, so looking at the south component first. Okay, so there's my south component. And when I look at that compared to the line S, I can see that, the S is 114, which is the size of it. They gave us that. And that's the cos of 70. Okay, so 90 minus 20. And you can see there, I subtracted 360 minus 250 to give me 110. And then 110 minus the 90 degrees to give me the 20 and the 70. So a little bit of resolution of just your simple unit circle there and getting your angles right. And that was 39 south from my interpretation of it. Again, you could take it from a different angle, but that to me is the most obvious one. And then the other one is where it is, you can see down the end of my page there, I took the cos of 20. Again, you're closing down on that line S, so that's why it's the cos of it. 114 cos times 20, which gives me 107. There's quite a few ways to do that, and I tried a lot of ways that will look like the answer the other way around, and they're also correct because what it said is identify fully the direction of each component using the compass. That's the important thing. So depending on what way you looked at it, and so you could use sine as well in different angles. If you went upwards, you would have them in the opposite way around, but that to me makes the most sense. It seems to be the clearest one. And then actually the other page became quite easy because the formula speed is equals distance divided by time, which you learn in first year. That's just rearranged. Time is displacement divided by speed. So 114 divided by 171, which gives you 0.666 recurring action. The calculator, which we all know is 2/3 of an hour. Now I know the marking scheme also allowed 40 minutes, but really when it gives you it in hours, you give it back in hours. Now the next one again is all relative. So you can see there I've plotted and I explain why we use 171 again. Okay, because the same journey, but the wind, and you can see the wind speed is coming down along. So I've just taken that little triangle. Okay, I have drawn it the right way around because I don't like looking at things upside down. So there's 36 and 171. And I found the resultant, which is 175, using Pythagoras' theorem. And then there's the angle in between. I have it up there in the diagram as well. You can see it up there. And then down here. And therefore there's tan of the angle. So tan of 36 divided by 121, tan inverse. And I got 11.89, which is 12 degrees. So actually quite easily done there. Okay, I hope that makes some bit of sense. And if there's any other questions, I'll ping this in an email to you and you can just email me back and I can get on to you or send me a picture of it and I can go through it like this as well. Okay, I'll see you on the 23rd, I think. So in week and a half's time anyway. Best of luck with your tests. Bye.